Are there any questions before we get started? Okay, well then would you please go to your lab stations?
Marie DeLuca has designed a laboratory experiment for her 8th grade science class that differentiates the activities or process. All the students are exploring the same concept, that differences in water temperature create currents. What the teacher has differentiated is the way the students explore that concept.
What it means to differentiate activities is to give students a variety of ways or alternate paths to making sense out of, trying out, manipulating the ideas that they worked with in the content.
We already did 2, 4, 6, 8, 10. Yeah, and then allow a minute or two for the thermometer. The 6th one.
These students are asked to measure the temperature of water at several depths over a period of time. In the first stage, they add ice to the water. After predicting how water temperature will respond, they record the temperature readings every 2 minutes and create graphs to help analyze the data. Later, they'll repeat the procedure, replacing the ice with heat from a lamp, and graph those results.
The at grade level students would have to read the thermometer and then in their head really begin to formulate a hypothesis as to what was happening. They have to construct their own data table and they have to graph the results before they can start analyzing the information.
It is 13, 20.
Very nice. Yes, you have to set up the experiment.
For students who would struggle with recording 6 temperature readings every 2 minutes, Marie has given them a computer program that records temperature readings and automatically generates a graph. This allows the students to focus on analyzing how temperature differences cause water currents.
What the computer does for the group is it eliminates the tediousness of having to graph the results, which some students really struggle with, so that they can see trends immediately and can begin to come to conclusions. They still have to make the predictions, they still have to manipulate the equipment, but it takes away some of the frustration they might have with the graphing itself.
Yeah, what predictions did you have?
For students who are more advanced in their understanding of the relationship of water temperature and currents, Marie has set up an activity that will challenge them in analyzing data. Through a Laserdisc program, students are presented a problem to determine the cause of a heavy fog that has engulfed a harbor this summer.
We have the only nice beach around, but nobody's coming. What's causing this fog?
Students can access interviews with local residents and experts, written documents, weather maps, information about a nearby nuclear power plant, and other data.
They should have at least some idea of where they're headed. And so I asked them to write down a hypothesis. And then, keeping that in mind, look at all the evidence and then either discard it or accept it.
For our hypothesis, we should put that the pipes coming from the plant are warm and it's causing the lake water to be warmer and it will evaporate quicker, and this evaporation mixes with the cold air and that causes fog.
Now, embedded in the interviews, though, are distractors, things that are meant to throw them off the track. So they have to really be focused and eliminate things that don't belong there. This is a higher order thinking task because they have to be able to look at different sets of data, and then they have to put everything together and evaluate the data and then come up with the conclusion.
Just like the thing we saw about the cold water and the warm air.
Right, and that could be forming the
And that's
fog.
what's making the fog. Yeah, so
The warm air passes over the cold water.
It forms fog. That's very good. Now, why wasn't that problem there before?
Because
there
that
was
El
no
Nino,
cold water for it to form all.
Because of El Nino. What happened with El Nino?
it changed
It changed the temperature of the water.
For years, it was coming up to that bay, and it
now
was
it's
bringing warm water, and now it shifted, and so now suddenly the water has become cooler. And that's what was causing the fog. Now, the power plant, you were right.
In differentiating activities, once again, we might look at the activities on a series of continuums. For example, from simple to complex. Students in this class who have some difficulty with science materials are able to use computers to help them chart data. That's a fairly simple approach which gives them access to the idea that they're studying without having to become bogged down in management of all of the data itself. Students in a more sophisticated group are actually having to manipulate the data themselves, use the equipment, chart the findings, and interpret them. That moves from simple to more complex. Students who are at a greater level of complexity not only have to analyze the data and manipulate it, but they also are given a data set that has some unnecessary or extraneous variables. They have to decide which data to use, how to use it, and how to chart it.
It's important to understand that differentiation of instruction doesn't mean coming up with a variety of different and unrelated activities. Differentiated instruction really just has to begin with good teaching.
It's very important for a teacher to know what he or she wants her students to be able to know, understand, and be able to do as a result of a particular segment of learning. So what that means is then that a teacher focuses on a key concept and a key skill that helps the students work with that concept. The teacher then designs activities that cause all of the students to work with or make sense of that same big idea and use the same basic skill, but at different levels, for example, of simplicity or complexity, concreteness or abstractness. That way, all of the students are getting an opportunity to make sense of or deal with the essential understandings, but at levels that provide an appropriate degree of challenge.
What material or what substance is present in largest
There are
amounts?
times in all classrooms when it's more effective or efficient to share information or use the same activity with the whole class.
Most of the information I'm presenting, they've had some background on it, but they really do need teaching on it. And so you always have to have whole lesson activities. Now, why is it that the salt is not leaving the ocean?